Welcome to AP Calculus BC video for skill number 205. I can simplify exponential expressions and draw connections between exponential functions.
Alright, for this skill we are going to be looking at laws of exponents and learning how to simplify expressions with exponents. Generally this is covered in pre-calculus, and you do have several of them in Calculus AB. So by the time we get to Calculus BC, we should have these pieces down. But the general laws, the very common laws I've listed here, ax times ay becomes a to the x plus y. You have to have a common base. Similarly, if you do the division, we subtract the exponents. If we raise a to the x to an exponent, we need to multiply those two exponents. And then also finally the exponents does distribute into a set or a group in this fashion. So I've listed a few examples down below here with example 1 and worked through them, starting with a relatively easy one where we apply the division of exponents. So the 5 subtract 2 becomes 3 to the third, and we simplify it to the 27th. We're getting a little bit harder where we have a root and we have to translate the root into a fraction, and then we can subtract the exponents. Don't forget, if there's no exponent shown, it is a 1, so we can go 1 minus 2/5 and get 3/5. The third one is distributing the 4 in, so the 4 times -5 is -20. Fix that typo. The 4 times the 3 is 12, and then the 4 does not go to it because it's not in the parentheses. We're then able to combine the a squared times a to the -20 and get a to the -18th. The b stays by itself, and for my classroom I prefer no negative exponents, so I move the a to the 18th to the denominator. That property says a to the -n can become 1 over a to the n, which you should all be fairly familiar with. My classroom, I don't like negative exponents, but on the skills you practice on Khan Academy, I believe he's accepting of negative exponents. Here we're getting to the point where our exponents are actually functions, which is where it's kind of becoming BC territory. And what we can do is we can add those two functions together using our exponent addition property, and then we have two functions above each other and we can subtract them, finally giving us g to the 4x minus 4. This example is just several iterations of this. I'll leave it to you to look through it. This one I translated the radicals into exponents, so the 4th root of a become a to the 1/4, and then the whole quantity is raised to the 1/3. Alright, in example 2, it says, show that 4 raised to the 2t squared minus 3t plus 1, all of that as an exponent, can be represented each of the following ways, and I give you 3 ways. And really what I'm asking here is for you to practice the properties and see if you can manipulate the given way so that it winds up looking like what we start with. So in this one I've distributed the exponent in, so 2t minus 1 times t minus 1, and we find that it's the same value as that exponent as we started with. In the second one, I distributed the exponent, and then I had this floater 4, which I wrote as times 4 to the 1, and then I used the addition of exponents property to make that exponent the same. The third example actually took a little bit of thought for me working through, but first thing I did is I put the 16 in parentheses, and I was able to make that 4 squared. So now I'm seeing this 4 to the 2t squared, and then times 4 to the 1. That's on the numerator. And then the denominator I wrote in terms of 4 as well, 4 to the third t. And with those three pieces, I was able to write them out and arrive at the answer. This is a interesting, difficult one in this bunch. I actually pulled this question off of the Khan Academy site and just slightly modified it. So you'll probably be expected on Khan Academy to do calculations similar to this. Let's look at the final example. Find the exponential that passes through 115 and 275. So what we have is a curve that passes through 115 and way up here 275. And I'm asking you to find the equation f of x is equal to some number times some base raised to the x power. So the way I go about doing that is, this is our target goal, and I know that f of 1 will look like this, c times a to the first, and that is equal to 15. So c times a to the first is 15, and c times a to the second is 75. Which means, if I simplify each of those, I can solve both of them for c and get c equals 15a. Sorry, c equals 15 over a, and c also equals 75 over a squared. So I set c equal to c, and I get 15 over a equals 75 over a squared, and I go about solving that out using algebraic properties, and I arrive at the final answer that a has to be either 0 or 5, and if it's 0, then it's not an exponential. So we know that a is 5, and we can plug that into our c equation to solve for c. So we finally arrive at f of x equals c times a to the x.
This concludes the video for skill number 205, Calculus BC. Thanks for watching.
I did not really cover in the notes the drawing connections, but that would be something like plug 2 to the x and 1/2 into the x into the calculator and talk about how those two functions are related. Or maybe 2 to the x, e to the x, 10 to the x, 50 to the x. The sort of relationships I'm talking about is these are all growth exponentials. These are mirror images, or these are reflections of one another. So that's all I really care about on the drawing connections.